In this video, we have two learning goals. The first one is to write the name of an ionic compound, but this time with a polyatomic ion. A polyatomic ion. And then we're also going to be able to write the chemical formula of that ionic compound that contains a polyatomic ion. So let's get to our first goal. But just a reminder, first of all, that there is a difference between monatomic ions and polyatomic ions. So recall monatomic ions, they are the simple ones. You can just recall what their charge is just by looking at the periodic table. Now polyatomic ions, these are ions that have multiple atoms. So again, the example is NH4. That clump of atoms there, the multiple atoms there, they all combine to have a total positive 1 charge. Okay, that's the ammonium ion. And then this CO3 here is this example. This clump of CO3 atoms together, okay, in total they have a -2 charge. So this is polyatomic ion. This one's called a carbonate ion. Now, you can see on the right here, this table, this should look a little bit familiar because, based on what we last learned of transition metal ions, the transition metal ions are here, but now the polyatomic ions are also listed here. Okay, there are polyatomic ions listed here. What I want you to do is think about which one of these are polyatomic. Which one of these ions are polyatomic? So pause the video and think about it first. Okay, so hopefully you thought about it. First of all, I'm going to go ahead and highlight the ones that are polyatomic. So acetate. Acetate, there's two forms to write it, but it's polyatomic. It has a -1 charge. We have hypochlorite, is polyatomic, it has a -1 charge. Chlorite, which looks similar, but there's an additional oxygen atom, that's also a -1 charge. That one's polyatomic. There is chlorite, that's chlorate. Okay, so just be very careful. They are named very similarly, but they are different. Okay, there is a difference in the number of oxygens, but they all seem to have a -1 charge. Perchlorate, cyanide, carbonate, these ones are polyatomic. And then on the second column, let's see, we have chromate and dichromate. These ones have -2 charges, but their amounts of chromium and oxygen atoms, they differ. So be careful about that. We also have bicarbonate, that has a -1 charge. We have permanganate, that has a -1 charge. And ammonium, that one has a +1 charge. On the third column, let's see, what else? We have NO2, NO3, these both have a -1 charge. We have OH, that has a -1 charge. That one's polyatomic. PB is actually a single element, so that's not polyatomic. We have PO4, that's phosphorus and oxygens, right? So that's polyatomic. And then we have SO3, SO4, they're slightly different. They're both -2, however. And then that should be it. So all of these ones highlighted in green are polyatomic ions. Be very careful. Some of them are named very similarly, but they are not exactly the same. There's another question down here that's asking, are these polyatomic ions mostly cations or mostly anions? So remember that cation means we're talking about positive ions. Anions are negative ions. So are these polyatomic ions mostly positive or negative, basically? Pause the video and think about it. Okay, so here's the answer. Pretty much all of these polyatomic ions are negative. The only exception is ammonium. Ammonium is the only polyatomic ion here that is positive, right? So to answer this question, these polyatomic ions are mostly anions. They're mostly negative ions, okay? Alright, now here's our first learning goal. Write the name of the ionic compound with a polyatomic ion. So step 1, name the ion first. Step 2, or name the first ion. And step 2 is name the nonmetal ion with an IDE suffix. However, if it's a polyatomic ion, then name it exactly from the list. Okay, so let's see. This first question, or this first chemical formula, we have Ca is a metal ion. It's monatomic. That one's calcium. Okay. Now CO3, that's actually a clump of atoms together. You won't find CO3 on the periodic table because this is carbon and 3 oxygens. This is a polyatomic ion. We can find this on the list. CO3. Now be careful because right here it looks like this CO and then plus 3. That's a cobalt ion with a positive 3 charge. We're looking for CO3 and the 3 is a subscript, right? Now CO3 has a negative 2 charge, but that doesn't matter. CO3 is called carbonate. So we're going to write carbonate. So this second ion is a polyatomic ion called carbonate. And that would be it. We just name it exactly the way it's spelled on the table right here. Now we have MgOH2, and there's a parentheses. Okay, what the heck do we do with parentheses? I'll explain it in just a second. So Mg is just magnesium. You can find it on the periodic table. What about this? What is this whole thing right here? Well, this parentheses is just showing you that there are 2 of these OHs. Now, what is an OH? Right? What is an OH? If you look at the periodic table, you won't find capital O, capital H, right? Because these are 2 separate elements. So this must be a polyatomic ion. And what we're going to do is we're going to look at the right. If you identify it, you'll find that it's in the 3rd column. OH has a negative 1 charge, but the negative charge doesn't matter here. What we're looking for is a name. It's called a hydroxide. Okay, so this OH here is called a hydroxide. And if it's in the parentheses, and there's a 2 outside, that just means that there are 2 hydroxides. There are 2 hydroxides here. But it doesn't matter. It's still called hydroxide. So I'm going to add the name to this ending right here. It doesn't matter that there are 2. We're still going to name it the same way. So this compound is called magnesium hydroxide. The next one we have the same situation. There's a parentheses. And there's 2. It's just telling us that there's 2 of this polyatomic ion in here. Okay, NH4. NH4 is nitrogen and 4 hydrogens, but that is polyatomic. You can find it all the way down here. NH4 has a positive 1 charge. The charge doesn't matter. What we're looking for is your name. It's called ammonium. Ammonium. Okay, and then the O right here, recall, okay, this is not a polyatomic ion. This is just a regular monatomic ion, single atom ion, right? And if it's a not polyatomic, it has to end in IDE. So this is oxide. Right, so the name of this is ammonium oxide. Now before I move on to do a little bit of practice, I do want to let you know that this right here, okay, this last example, ammonium oxide, is really like the only type of example where we don't have a metal at the beginning. Because remember when we were first learning about ionic compounds, the general rule is that it's a metal with a nonmetal. Well, if you take a look at this, ammonium is NH4. N and H are both nonmetals. O is also a nonmetal. So this one seems like it's a covalent compound, but this one's still ionic. Because in ionic compounds, if you really think about the name, it has ions, right? Ammonium is an ion, oxide is an ion. So this is an ionic compound, even though there are no metals here. This is the only exception where you won't find a metal in the ionic compound. Okay, just wanted to point that out. Okay, now we have some check for understanding questions here. So pause the video, try this on your own, and resume it to see if you got this correct. Okay, use the table, it's going to be helpful. Alright, and here are the answers. Now for the first one, we have an ammonium ion, and we have a sulfite ion. Please be very careful. The sulfite ion is one called sulfate, which is SO4. It's very close to SO3, but SO3 is sulfite. For the next one, we have potassium ion with a chlorate ion. Now, be careful with the chlorate ion because there's a bunch of other ones that look like it, but the one with 3 oxygens, okay, ClO3, that one is chlorate. And the last one we have aluminum ion with a chromate ion, okay? All right, now our second goal is to, I didn't have the objective changed right here. Well, it's to write the chemical formula of the ionic compound that contains a polyatomic ion. So for here, just know that you should refer to the table, and the only reason I don't refer to the table is because just, you know, I've done so much practice that I know what these ions are. So yeah. Alright, right here, it's almost the same as the previous two practices with the monatomic ions and with the transition metals. The only difference is step 3. Okay, step 3 is the only difference. And it's right here. Polyatomic ions need a parentheses if there's more than one of the ion. Okay, I'll show you what that means when we arrive at that example. Here's the first one. We have sodium, which is Na. Sodium has a positive 1 charge. Carbonate, if you look at the table, it's CO3. Carbonate has a negative 2 charge. I'm just going to double check, just real quick, since we're learning it here. CO3 negative 2 for carbonate. Okay, CO3 negative 2 is right here. Okay, CO3 negative 2. Okay, now are these balanced? Now focus only on the charges. We have 1 positive charge and 2 negative charges. It's not balanced. We're going to need more positive. So I'm going to duplicate the sodium ion. I'm going to write another one down here. There we go. There's another sodium ion. Now there's positive 2. It balances out with the negative 2, so I can go ahead and write the formula. There are 2 sodium ions here, right? 1, 2. So as a subscript, I'm going to write a 2. And for the carbonate ion, how many is there? There's only 1. There's 1 carbonate ion. So I'm just going to write CO3. Okay, in this case, there's only 1 polyatomic ion for the carbonate. So yeah, I don't need a parentheses here. So this is the answer, Na2CO3. For our next example, we have ammonium phosphate. Now ammonium is NH4, positive 1. I'll show you real quick where it is on the table. Okay, ammonium is NH4, right here, right? It has a positive 1 charge. Ammonium, positive 1 charge. And then the next one was phosphate. Now phosphate is I think it's PO4 negative 3. Let me just double check since I'm not certain. Phosphate is right here. PO4 negative 3. Okay, so PO4 has a negative 3 charge. There we go. So look at the charges. Do they balance? One of them is positive 1. The other one is negative 3. So no, it's not balanced. I'm going to need more positive, right? So I need to duplicate the ammonium ion. And, you know, if you've done enough practice, you probably know I need 2 more of these ammonium ions. So I'm going to duplicate it twice. Right? Each ammonium ion is positive 1. So if I have 3 of them, a total of positive 3. That cancels out with the negative 3 from the phosphates. So I'm going to go ahead, draw this line right here. It's balanced. I just need to know how many ammonium ions there are. So I'm going to write NH4. Now how many ammonium ions are there? Now this is 1, this is 2, and this is 3. Now here's the thing. We usually write it right down here, right? But it would look weird if I just wrote a 3 right next to that 4. It would look like it's saying NH43. But that's not right. Ammonium is not NH43. Ammonium is NH4. Okay, so to fix this, this is where this comes in. Polyatomic ions need a parentheses if there's more than 1 of the ion. Alright, we've got 3 of these ammonium ions, so we need a parentheses. So I'm going to throw in a parentheses right here, right around the ammonium. And now I can indicate how many there are. We said there are 3, so right here, right after the parentheses, I'm going to put that 3 right there. Okay, there's 3 of these ammonium ions. Hopefully that makes sense. For the next one, we have a phosphate ion. A phosphate is PO4, right? We don't need to include the charge. We're just writing PO4. And, according to what we have for our work up here, there's only 1 phosphate. Since there's only 1 phosphate, and there's not more than 1, we're not going to need a parentheses. So we're just going to leave it as PO4. Okay, so this right here, NH4 3 PO4, that's the chemical formula for ammonium phosphate. Okay, let's look at one more example. We have magnesium. Magnesium is just straight off the periodic table. Magnesium is in group 2, so it has a positive 2 charge. Cyanide, even though it ends in an IDE, it's actually not a monatomic, it's a polyatomic. It's CN with a -1 charge, but let's just double check on the table. Okay, cyanide. Where is it? Oh, here it is. Cyanide, CN, and it has a -1 charge, okay? So again, you just have to recognize that these are on the ion table, okay? Alright, are these charges balanced? Well, we've got a +2 magnesium. We've also got a -1 cyanide. No, there's more positive than there's negative, so I'm going to need another cyanide ion. Duplicate it. Alright, there's another one. Now, the amount of negative charges is now -2, so that balances with the positive, so I can go ahead and write the chemical formula. So, how many magnesium ions are there? Well, there's only 1, so just leave the subscript blank. How many cyanide ions are there? Well, there's 2. Okay, there's 2. So if I write CN, okay, and if I write a 2 right here, that's actually incorrect. Okay, CN is cyanide, not CN2. So to correct this, okay, since we have 2 polyatomic ions, we need a parenthesis since there's more than 1. We need a parenthesis. So I'm going to fix this real quick. I'm going to put a parenthesis around the CN. And since, again, there's 2 of them, now I write after the parentheses that there's 2 cyanides. Okay, 1 magnesium ion, and then 2 cyanide ions. Hopefully that makes sense right there. Okay, here's the last page. This is just 3 check for understanding questions. I want you to pause the video and give this a try, and resume once you have tried it and see if you got it correct. Alright, here are the answers. Okay, I just had to backtrack to see if I wrote down one of the ions correctly, because I guess I have a fuzzy memory. Okay, so check it out. And I guess the only one I want to comment about is this first one right here. Now acetate, there's 2 ways to write acetate. You can write CH3COO or CH2COOH, I believe. There's 2 ways to write it, so whichever way you wrote it, I'm sure it's fine. But there is 2 of them. So you do need parentheses here. Alright, hope you found this video helpful.